Welcome everyone to Exploring Stellwagen Bank National Marine Sanctuary Expedition 2020. Today's program focuses on exploring the mystery schooner, the unidentified shipwreck in Stellwagen Bank National Marine Sanctuary. I'm Hannah McDonald, Education Specialist with NOAA's Office of National Marine Sanctuaries. Today, I'm located at the Inner Space Center at the University of Rhode Island. On screen with me today, you will see the research team located in Scituate, Massachusetts, as well as an underwater feed. Now, this underwater feed is coming from a remotely operated vehicle. In our previous programs, this ROV feed was coming to you live in real time. But due to unfortunate weather circumstances, which you may even see our team are experiencing at the outdoor location, and these high seas here, we had to bring our marine technology team and marine operations to shore. This means that you get to ask your questions to the marine technology team, but any of the underwater footage has been pre-recorded. Now that I'm noting unfortunate weather circumstances, I wanted to shine a light on what's happening in the Gulf of Mexico with Hurricane Laura and send well wishes to all of those being impacted down there. The ocean is all connected, so it's very important to acknowledge those coastal communities being impacted as we speak. This model that I've referred to, though, that brings in live ROV feed to scientists ashore and then to all of you is called telepresence. And it's what enables us to connect to all of you during this national health crisis. Woods Hole Oceanographic Institution and NOAA's Office of National Marine Sanctuaries are leaders in ocean science and exploration. They're committed to maintaining this mission while also ensuring the safety of their staff, their partners, and all of their families by following local, state, and federal guidelines. As you can see here, I am in mission control at the Inner Space Center. I have my mask for when I get to interact with the production team, but right now I'm all alone and I get to share my smile with all of you. As I've mentioned, our research team is in Scituate, Massachusetts. They are outside as well. So they are also far apart from one another, so they get to share their smiles with you. If you see people wearing masks, that means that they're close together and communicating with each other to answer your questions, making this as interactive as possible. And as I've mentioned, you are all a part of this broadcast too. Today we have viewers from Holyoke Community College as well as Bayview Elementary joining us today, and as well as the places that are listed on the screen. But I know we have a lot of live viewers streaming as well. So this is a great opportunity to type your location into the chat box and let us know where you're coming from. You can also type your questions, comments, anything for the research team in there as well to be addressed throughout the show. Right now, I'm going to turn it over to a little bit of a sneak peek video about this year's project.
842 square miles. Up to 600 feet deep, the final resting place of hundreds of shipwrecks, and one of the top 10 whale watching destinations in the world. Located 25 miles off Boston, Stellwagen Bank National Marine Sanctuary is home to a rich assortment of marine life, including Atlantic cod, haddock, flounder, bluefin tuna, and many species of whales, including the critically endangered North Atlantic right whale. Stellwagen Bank also contains vast numbers of shipwrecks, ranging from wooden sailing ships to modern fishing trawlers. These wrecks are both windows into the past and important habitats for marine life. Stellwagen Bank Sanctuary is one of 16 marine protected areas within the National Marine Sanctuary System, a network of more than 600,000 square miles of underwater parks. Managed by the National Oceanic and Atmospheric Administration, the sanctuaries promote responsible, sustainable use of ocean and Great Lakes resources. To foster the public's connection with the ocean, NOAA awarded funding to Woods Hole Oceanographic Institution, often referred to as WHOI, to conduct state-of-the-art research. Based on nearby Cape Cod, WHOI is the world's oldest and largest nonprofit ocean research and education institution. In 2019, tools and technologies pioneered by WHOI and their partner, Marine Imaging Technologies, let us share high-resolution images and interact with viewers in real time. This year, those same remote tools allow us to carry on our work during the pandemic. In early March, we added innovative microwave technology that beams data to shore, providing faster communication and better images. And we adapted our research model to include a smaller crew at sea and broad distribution to partners on land. COVID-19 has changed many aspects of our lives. But with careful preparation, social distancing, and technology, we can safely continue researching the ocean floor and sharing our discoveries in real time with you.
I hope you enjoyed that sneak peek of this project. You are going to learn so much more from this research team during today's program. And I see you also figured out the chat box. Thank you for letting me know where you're coming from. We have an international audience today. We have viewers from Oslo, Norway, Las Vegas, Nevada, and even a little bit closer to Stellwagen Bank National Marine Sanctuary with Falmouth, Massachusetts. So welcome all viewers. Again, this location where you let us know in the chat box, that's where you get to type in your questions to the research team throughout the program as well. So now it's time for me to introduce you to the first member of the research team, Deputy Ben Heskel. He's Deputy Superintendent of Stellwagen Bank National Marine Sanctuary, braving the weather for us today. Hello, Ben.
Hi, Hannah, and howdy everybody out there, even from Norway apparently, so that's fabulous. So I'm standing here on the back deck of the Marine Operations Center in Scituate, Massachusetts, and today we're going to be talking about the mystery schooner that sits out in Stellwagen Bank National Marine Sanctuary. So coal-carrying schooners were once constant visitors to the area that is now Stellwagen Bank National Marine Sanctuary, transporting coal up and down the East Coast. But at the time, it was a really important energy source. It still is an energy source, but unfortunately, we know now that it's causes a lot of pollution. But back then, coal was one of our primary sources of energy, and to get it up, transport it, we used these coal schooners, otherwise known as colliers, and you know, we needed the coal for heating the homes and transporting, using in trains and powering our factories, but out in the sanctuary, we have a variety of different examples of coal schooners, two of which are absolutely massive schooners that collided bow to bow, and is one of the most dramatic scenes of a shipwreck that you'll ever see anywhere in the world, and it comes right here from Stellwagen Bank Sanctuary. And this image, or this side scan sonar image, is of these two absolutely massive coal schooners that collided in 1912. So what you're seeing is the wreck of the Crary, Louise B. Crary and the Frank A. Palmer that collided, racing each other essentially into Boston, trying to be the first to unload their load of coal. They each had like 3,000 tons, so they sank like stones after they collided, and now they're sitting on the seafloor upright, as you see in the image. But today we are talking about a much smaller coal schooner, the name of which we don't know yet, or the identity of it, but documenting, you know, these historic wrecks in the sanctuary is part of our mission. So we have basically a dual mission to understand and protect the historic resources of the sanctuary, as well as the natural resources. So so that's what we're attempting to do, and with every wreck that we investigate, we learn something new about our maritime past, and our country has a very rich maritime past, and was, in fact, built on our maritime traditions. So this coal schooner that we're discussing today is about 100 feet long, and we've noticed some odd numbers on the bow stem of it. We've also noticed that it's covered with copper sheathing to preserve the hull and keep the fouling organisms off. And so we're using these various diagnostic features to try and determine its name. And Dr. Calvin Myers will talk more about that in a minute, but right now I guess I'll turn it back over to you, Hannah, and we'll take it from there.
Thank you so much, Ben. You mentioned documenting maritime history. And in my mind, there's one great tool that we've been using to help do this throughout this project, and that is marine technology. Before I turn it over to this video that's going to tell you a little bit more about the marine technology used in this project, I wanted to open it up to all of you to, during this video, type in a question that you may have about marine technology. Our next guest on screen, next member of our research team, will be the marine technology team. So they'll be able to address your question. So again, just type that in the chat box during this next video.
Deep sea research and exploration are completely dependent on technology to go where humans can't. At Stellwagen Bank, we use a remotely operated vehicle, or ROV, named Pixel to take pictures and video around shipwrecks. Pixel is relatively small, a fraction the size of deep sea ROVs. But sometimes we need something even smaller to advance our scientific goals: a penetration vehicle. This year, Marine Imaging Technologies built one, the Portland Penetration Explorer, or PPE, designed to go inside shipwrecks. PPE hitches a ride to the wreck on Pixel, then flies off and explores places even Pixel can't go. Looking inside the Portland helps us gather more information about her final moments. PPE's wide-angle, low-light 4K camera captures images from deep inside, where light is often scarce. These same images will let us build a future VR experience based around the Portland. One of our biggest technological changes this year is not underwater, but in air. Telepresence typically involves broadcasting via satellite, or VSAT. But VSAT equipment is large, heavy, costly, and poorly suited to small vessels. Due to the COVID-19 pandemic, we're operating with a reduced crew on a much smaller boat, the Catapult. We needed a solution that provided real-time communication to partners on land, but that Catapult could still fit and operate. So we partnered with AV Watch, who provide high-bandwidth communications for the U.S. Coast Guard, Air Force, and Navy. They pioneered a new way of using microwave broadcast technology, pairing small, stabilized transmitters at sea with equally small receivers on land, or even on a plane. Their technologies provide high-bandwidth data at a fraction of VSAT's cost, letting us send multiple real-time video feeds to our team ashore and helping everyone stay safe.
I don't know about you, but I am super thankful for the microwave technologies that bring us together today. And they're even connecting Mike's sister, marine tech operator, to this program today. So shout out to family members for tuning in. And Evan and Mike, we have a question for you, and it's, why do you need these two ROVs to explore the wrecks?
Well, that's a great question, and I will probably both have overlapping answers. So I'll start. But for me and for a lot of the imaging work that I really like to do, it's about having the right tool for the job. And Pixel has been a fantastic tool to get us in and around the wreck in many places that we couldn't get with a larger vehicle. But sometimes, quite literally, there are spots that we want to get inside and have a look at, particularly for Calvin, to get in and help answer some of the lingering questions they have regarding why the Portland ultimately went down. I mean, there's also just the fun of building something new. But anyway, Mike, I'm sure has something to say.
Yeah, like Evan said, the fun of building something new, but it's also handy to have two ROVs down there. They can light things better for the imaging, get a better picture of what's going on. And with the smaller vehicle PPE, we can actually go inside some of the rooms and openings that are available to go help identify more features of the site. And so even yesterday we managed to get into the boiler room area, look at some steam pipes, things like that, areas that have not been seen since the Portland went down many years ago.
Yeah, it gives us the ability to get almost diagnostic in the on the inside of the wreck, which is just almost impossible to do otherwise.
Great, thank you so much. And you're both on shore today, which wasn't necessarily the plan. Could you speak to what brought you on shore and maybe some of the challenges that you had to face as you were returning to shore from the strong seas earlier this week?
Sure. Well, one of the great challenges of working at sea is the sea itself. We had weather kick up, and we went from not quite flat calm, but reasonable seas to almost within 15-20 minutes, 3, 4, and it built all the way up to 6 feet. And of course, we were sitting on a 4-point mooring system with a lighting chandelier and 2 ROVs in the water. Lightning bearing down. It was a little sketchy. And this morning we went back out because the weather had dropped down, and we had hoped to spend the day out there. But even though it's nice and calm in here, there's a hook of Cape Ann, and I think that blocks a lot of the weather and wind and waves from a certain direction. And so once we got out past 10 miles, it quickly built up, and as we were recovering the gear that we had to leave the other day, we were literally burying the bow. I think Mike, even without the raincoat, was totally drenched. So.
Yeah, you notice I'm wearing pants and a shirt and jacket now. While we were out there, we got completely drenched, and I luckily had a change of clothes to get into. Otherwise, you'd be looking at me completely soaked, and it wouldn't be because of the rain.
We are so thankful that you both made it back to shore safely and that both Taz and Pixel are with you intact. That's all great news. We still have underwater footage to look at. Which brings me to the next part of this project. The underwater footage is also used by Dr. Kirsten Meyer-Kaiser to look at the biology, the sea life at the bottom of Stellwagen Bank National Marine Sanctuary. Hi, Kirsten.
Hi, Hannah. I would love to tell our viewers about the biology of shipwrecks, but before I do that, I want to take a moment just to honor the fact that it is raining right now. When we decided to push forth this year and do our research in the middle of a pandemic, we knew we were going to have to adjust our plans several times by the end of the year. And now this is actually our last broadcast, and we have had to adjust one more time, putting all of the electronics in a safe place out of the rain. And I find it just so fitting for this. Since this is our last broadcast, I wanted to just kind of review some of the highlights of what we found living on the shipwrecks that we've investigated last year and this year as well. On Tuesday of this week, I think the major highlight for all of us was that we were able to penetrate the Portland Shipwreck using that small penetration vehicle that Evan and Mike have been telling you about. And for me, it was really interesting to see what was living inside the Portland. I dive on a lot of wrecks, and usually if I dip my head inside, there's not a lot there. It's maybe a couple little tube worms. But inside the Portland, I was surprised to find that there are actually some sponges. They're living on and around and over all of those structures. They kind of look like just white blobs in the footage, but there's sponges there that are living and feeding off of particles in the water column. There's also sea stars, 2 different kinds, a blood star and a horse star that I could see in that footage. And there was a cusk that was using those habitats down in the wreck where it's very nice and protected to make its home. That was really exciting for us to see. Of course, it's always exciting when we get to see a new shipwreck for the first time. And this summer, that was definitely the case for me with the Mystery Coal Schooner. That was a wreck I had never laid eyes on before. And so as we approached that, I had just in my mind that first level analysis of what is there. And in the case of the Mystery Coal Schooner, it's actually a pretty unique site because there's copper covering the hull on both sides. And copper is toxic to marine organisms, so they don't like to settle there. It's actually completely empty of any sessile invertebrates. The only place that those invertebrates can settle is on the wooden parts of the wreck, such as the knees, or there's some wooden debris laying around the wreck site. The fish were still definitely around that wreck. We had Acadian redfish and cusk that were using those habitats, using the structure provided by the wreck for their protection and for nursery areas for their young. It's a really essential role that shipwrecks play. And then one of the other highlights, I guess, for me was earlier this summer, we were able to collect some specimens of 2 species that I was struggling to identify visually. Usually I can tell what things are just based on previous experience or photographic taxonomic identification guides, but there were 2 things, a sea squirt and a sponge. So using custom-built suction samplers on Pixel, we collected 2 specimens from a boulder reef. This is a natural hard-bottom habitat close by, and we decided to go there so that we could protect the wrecks and not risk damaging them by scraping off those specimens. I was able to preserve them on the boat and then take them back to my lab at Woods Hole Oceanographic Institution for analysis. I dissected them under a microscope, which was a lot of fun. I love getting my hands into those small characteristics of organisms that help me identify them. And by comparing to published taxonomic keys, I was able to get the sea squirt down to genus and the sponge to species. It was really exciting. So it is bittersweet for this to be our last broadcast, especially in the rain, but I am so grateful for the work that we've been able to do in Stellwagen Bank National Marine Sanctuary. And with that, I will hand it back to you, Hannah.
Thank you so much, Kirsten. And I really think you showed such a great example of how interdisciplinary this work is, with the ROV being able to collect samples for you, and then the highlight being Taz penetrating the Portland. That's so exciting. There's one other aspect of this project that we haven't covered yet, and that is the maritime archaeology aspect. Now, I know that we have students coming in from Stonehill University. Now, these happen to be Dr. Kelvin Meyer's students. He is the lead maritime archaeologist a part of this project, and he's having them tune in as one of their first classes. So welcome to you, and with that, I'm going to turn it over to Kelvin.
Thanks, Hannah. I really appreciate that, and hello to all the students. I was watching the video right here of the Portland footage, and I almost forgot that I had to talk here because it's mesmerizing. And one of the things that the project has done is provide these images, even though we're not out on the water or on the water, but the water's come to us. With these images, we can get high quality information and virtual data from this, and they're creating a 3D model, and all of this really comes into play maritime archaeology. For every hour of field work we do on the water, which is a lot of fun, the most fun I think any field archaeologist would tell you, it's 3 to 5 hours, maybe even more back in the lab, going through trying to figure things out. Even as I was looking at the monitor here, I was seeing, pipes and exhaust and various features, and I was leaning in. But that's part of the fun, as well as working with a great team and working in the environment. So one of the questions we always get asked is, what is this shipwreck? One of the first things that people ask, what is the identity? Sometimes that is, we get fortunate, and like the Portland, we know based on its features. Other times, like we have with the Mystery coal schooner, it's very difficult. There's no identification that's readily apparent, so we have to do that underwater detective work that starts with piecing the clues together. And this year was our first year of going and looking at it. And almost immediately when Pixel went down, we landed right on the bottom, right at the front, at the bow, with this stem, or the stem post, which has these numbers. And generally, these are water lines telling you where the ship sits in the water. But as we looked at them, they looked like 898, which is not sequential. So perhaps they're a bit of a license plate, or they're part of the water line with a certain numerology that we're looking into. But that's where it starts. And then Pixel did this great sweep, we call it flying down the wreck, where we started to see the frames and other artifacts that came to light. And we saw about this brass, looks like a harpoon almost, or a little torpedo. And this was a taffrail log. So what that is basically it measured speed, and they would lower it off the stern and lay it out behind the boat. And that would actually take measurements on how fast the ship was going. And it has these fins and a nice stabilizer on there. And that was patented in 1860. So you start to get a timeline. And for my archaeology students, you're going to learn what terminus postquem means pretty quickly. So write TPQ down in your notes. But for everybody else, let's just move on. So as we swing around the stern, you can see it in the monitor, that's the taffrail log. As we swing around the stern, we saw an artifact that I think everybody will recognize right at the back. This was a toilet bowl. And I've reached out to colleagues in Seattle that have worked on historic turn-of-the-century ships to get the idea of indoor plumbing. And as we looked at that, and as we went around the starboard side, we saw this really beautiful brass telescope, and it has its cap still screwed in there. And if PP was out there right now, we'd be looking really closely at this to see if there's any kind of marks. But some of the biggest features were right on the wreck itself. So one item that I believe Kirsten mentioned was the sheathing, this copper sheathing, which I've talked to colleagues in North Carolina, East Carolina University, and out in Flinders in Australia. So maritime archaeology is really an interdisciplinary science. It's kind of where history meets science, and you engage in a lot of different disciplines. And you use experts because there's not a monopoly on good ideas, as one mentor of mine once told me. So you reach out and you try to get the best information you can. And this type of copper sheathing is actually an alloy. It's called Munn's metal, and it's 60% copper, 40% zinc, and that was patented, 1830s, 1840s. So all of these are little clues, and the final clue is the most ubiquitous that's on the wreck: coal. Coal schooners, from the Industrial Revolution through the 20th century, coal dominated our energy source and these schooners were the semi-trucks of the day going up and down the coast, and most of them were carrying a certain type of coal like bituminous, which just has 40 to 60% carbon. But another type, anthracite, is sometimes called hard coal, and I have an example of it right in front of me that was given to me from Ben Heskel, the deputy superintendent. This isn't from the wreck, but it serves kind of as a visual aid. This type of hard coal had 90% carbon, and if we get a sample from the wreck and it had anthracite in it, this possibly gives us a clue, a hypothesis of the vessel's identity. And let me be clear, we're not saying that this mystery collier is the ship I'm going to talk about, but it provides, again, a working hypothesis. There was a ship that was built in 1882 and sank in 1908 in what the newspaper called nasty seas. It was called the Modoc, and it had a crew of 5, a 3-masted schooner, and a Beagle. Now, this was the first journey for the Beagle, and the sailors, who were all rescued, it had a happy ending for the sailors but not for the ship, started to call the Beagle a bad luck or a Jonah. But we all know that dogs can't be bad luck. There's no way that happened. And I say it's good luck because the captain raised a distress signal, and as the ship was foundering after 12 hours of 18 to 24 inches of water down deep in their hold that they're pumping furiously away, another ship saw them, the Rob Roy, and came over and through a harrowing kind of rescue effort brought all 5 of the crew members and the Beagle aboard and made it safely back to Boston. Unfortunately, the Modoc did not survive. It sank, and it was recorded in newspapers and matches some of the details by sanctuary staff as well as nautical researchers like John Fish, who helped find, with Arnie Carr, the Portland. And so we rely not just on professionals and colleagues, but managers and citizen scientists. Citizen scientists, avocational, passionate people have really helped us identify artifacts, clues, and other sites around Massachusetts and even in the region. And as maritime archaeologists, we love public involvement. We love the public engaging with us because that's the best way we get information. So I know there might be questions out there, and I'd like to turn it over back to you, Hannah, for some of that public engagement.
Yes, thank you so much, Calvin. I think your students are so lucky to see your work in action in real time at the very beginning of their semester, so that's very unique. I hope they ask some questions. This is now the time to type in your questions to the research team if you have not already, and we will turn it over to all of them. So that includes Ben, Calvin, Mike, Kirsten, and Evan. All of the team is there ready to answer your questions. And the first question that I have is coming in from online, and it's for Calvin. This one is about, it kind of combines the coal on the mystery schooner with the Portland wreck. Were you able to determine if Portland still had coal in its bunkers? And what about diamonds?
That is a really good question about the coal bunkers. With PPE, we were just taking a look at some of the footage, and we think we've actually identified where the coal bunkers were. I haven't been able to see too far in. This is kind of raw, real footage. Now, the other day there had been rumors that there could be diamonds. I haven't heard any of that about the diamonds, but a lot of times with shipwrecks, you will hear that treasure story. I've worked on Confederate blockade runners that had Confederate gold, but we never found any. Usually there's some German U-boats with treasure from Germany, and it captures the attention very well, but most of the time the real treasures are there of the everyday person, like the plates, the cups, the engine, things that we would take for granted, but really are representative of the essential worker. And I think that's the important part of archaeology. We're in an era right now, a summer of really recognizing the role of the essential worker, the frontline worker. And archaeology's job is to tell that story of those people, because they're mentioned in history books sometimes, but their story is often not told. So while diamonds are great and shiny and would definitely grab the headlines, I just get when you really get understanding those plates from the last dinner, like on the Portland, where a friend of mine's ancestor died on there. I think archaeology is a relationship with the site. So there's different ways to go about it. But to come back to it, we're excited about the coal bunker, and we'll keep our eyes open for diamonds.
It sounds like some of those artifacts are the real diamonds to the stories that you tell, Calvin. We have a question coming from Michigan for the ROV team. So this is, if the small ROV, PPE, or otherwise known as TAS, gets tangled, can the main ROV release it? And are there two different pilots? So I think we're talking to the right team for this question.
Okay, well, that's great questions. So let's see. Yeah, first of all, Pixel carries TAS, and there is a tether, of course, that feeds out from Pixel. And TAS actually, for this iteration, pulls the tether out. And that leads to all sorts of interesting scenarios. And when we're piloting, Mike's the chief pilot and the main pilot for all of the important stuff, as I like to say. And generally, Mike will pilot Pixel down to the site, and then take TAS out. And I'll work Pixel from there. And then as we work the two together, Mike usually runs TAS and I run Pixel. And Mike can tell you lots of stories about tangled tethers.
Yeah, so as Evan mentioned, when we get down there, ultimately Evan will start piloting Pixel and I'll start managing TAS. as we've now started affectionately calling PPE, just because she's a bit crazy to handle. But it is kind of a bit of a choreography, a dance, if you will, that we do down there. The tether will pull out with Taz, and then sometimes things will get spun around, or Pixel will have to move in a certain way that Taz's tether might get wrapped up on her, and so we'll get Pixel to spin around a circle to release it. Or in some of the footage you might see Taz actually doing barrel rolls to unwrap herself from her own tether when we come out of a penetration somewhere. So it's kind of an interesting process, and it's been a lot of fun to do.
Yeah, you guys get to see the footage. You get to see is literally just minutes of many hours on the bottom. And even if we spend several hours inside the wreck, we spend many more hours navigating around the wreck and just trying to manage those tethers. It took us some time. We've had a little bit of fun trying to figure out the best way to do that. But yeah, it's been a great process.
That's really good to hear that you figured out how to work together as a team to operate these ROVs. We have another question for you both, and this is about the 3D model of the Portland that you created last year. Will you be creating another 3D model of the wreck?
Sure. What we're going to be doing this year is continually adding to it. So in the video that you saw last year, for example, on the bow, we had a little bit on the port, we had a little bit on the starboard. And so what you can see right now, you see this big billowing net on the port side. Well, the matching part of that net is draped over on the starboard side, and last year we weren't really able to get that. We were learning how to work the wreck, and now you can see that whole starboard side filled in, and it's just literally draped in a net. And that's, again, that type of thing wouldn't be possible without, yes, cameras, lights, but without phenomenal piloting, where Mike can literally take that vehicle, read the currents, and just come right in, and it's a painstaking process of going up and down. And if you can imagine a very small paintbrush, and if Pixel had a paintbrush at the end of it, you literally have to go up and down to paint this whole wreck. But of course you're painting it with images. So we are going to be doing more. We've been off the wreck 3 weeks, and it took Marianne approximately 2.5 to 3 weeks to just process that net section. It's not an easy site from a modeling point of view by any stretch of the imagination. One of the key points of modeling is to try to have a straight, continuous path that never really leaves the wreck, and that's almost impossible with a small vehicle and the currents that we have down there. But so there's a lot of hand work that needs to be done on that model.
Sounds like a very tedious task. Our next question is for Kirsten, and it is about the plant life growing on the wreck, and if it can help determine the time frame for when the ship sank.
That's a really good question. Let me clarify one thing. There's no plant life on the wreck. Everything that we see are animals. There is not enough light at the depths where our two wrecks, the Portland and the Mystery Schooner, there's not enough light at those depths where they occur to support plant life. So some things might look plant-ish, but they're animals. Trust me. So there's, bryozoans that kind of look like algae, but they're really animals. There's hydroids that again kind of look like algae, but they're really animals. So there's not enough light down there for plants. And in theory, if we were to fully describe and understand the process by which a biological community forms on a shipwreck, then yes, we could use the biological community that we observe to estimate the age of a wreck. Unfortunately, there has not been enough research so far to put together that kind of a timeline, and actually understanding how a biological community forms on a wreck is one of the objectives of my research. I'm trying to lay that groundwork right now, put together that basic timeline so that in the future we might be able to, for example, for the Mystery Coal Schooner, use what's living on it to estimate its age, but we don't have that baseline quite yet.
Great clarification about the plant versus animal life. Thank you, Kirsten. We have a question for Ben Heskel, and it goes all the way back to the start of this program when the image of the two colliers were colliding. How did you conclude that they were racing to Boston? Could it have possibly been fog or a storm that caused the crash?
Well, it was a clear December night. We know that based on the accounts of the wreck. So basically, the historic record told us what happened in the incident, and that the mate of the Louise B. Crary made a serious navigational error, and so they were, within view of each other, and yet they still collided. It wasn't a particularly stormy night. It was a cold night, but clear. The historical accounts, in some cases, first person, allow us to know what actually happened.
Thank you so much, Ben, for explaining that story. I have another question for Kelvin, and that is from Dave. Do you collaborate with other organizations around the world in exploring newly located shipwrecks?
Great question. As I was mentioning before, yes. The short answer is yes. The field of maritime archaeology in itself is not that large relative to other fields, and you have experts who have looked, for example, at the mystery coal schooner, have studied copper sheathing through history. You have experts who understand ship construction. You have experts who seafaring and maritime heritage, and no one person can be the expert in all of these areas. I know a lot of really, really great archaeologists out there, and we rely on each other. So, for example, this time I reached out to a mentor and a colleague of mine, Dr. Nathan Richards down at East Carolina University, who shared with me a colleague of his, Dr. Mark Staniforth at Flinders University in Australia, and a friend and a former student out in Seattle, Nathaniel Howe, who has worked on historic museum ships. So within that, one of the great parts of exploration is not being siloed, not staying within your own field, but reaching out to others and cultivating a network of experts. So short answer is yes. A little bit longer answer is that's really where the information comes from. And as I mentioned before, avocations and citizen science provide a lot of information from their own research and history, and provide a lot of help. So it's not one person doing it alone, and former archaeologists here at Stellwagen Bank like Matthew Lawrence and Dee Marks. And you see, I've said a bunch of names because I've benefited from all of their efforts, and I'm very grateful and appreciative for everybody and all my colleagues out there.
It's great to see so much collaboration across fields and with all of these different colleagues and organizations to identify shipwrecks, and especially within this project. We have a question for Evan, and there was a mention of VR technology. Could you share a little bit more about that in reference to this project?
Sure. So some of the VR technology. Basically, what we are doing is using VR as a way, ultimately, to show the models. We had some ideas of putting some of the VR cameras on Pixel, which we just never really had an opportunity to do for live VR. So basically what we'll end up doing is bringing the model as we build it out into a VR environment, and sort of doing a simulator around it so that people can ultimately explore the wreck at their computer, in their living room, and stuff like that. So it'll be interactive and in the VR space. So unfortunately, it's not a live VR project, but that's what next year is for.
I think you have our viewers excited for next year with that, Evan. I'm going to take one final question, but I want to ask it to all Kirsten, Kelvin, and Evan, as this was one of the highlights of this year's projects. So what was the most interesting thing that you found with PPE? I say let's start with Kirsten.
Yeah, the most interesting thing for me that we discovered with PPE was honestly that there was just something living inside the wreck. Like I said, I dive on a lot of shipwrecks recreationally and for other projects for work. And usually if I look inside a wreck, there's not much there. And it was really surprising for me to even find sponges. If there was something there, I was going to guess that it would be a fish or a sea star, something that can swim in or crawl in, maybe explore a little bit and then come out. But the fact that there are sponges there was pretty surprising to me, because sponges sit in one place for their whole adult life and they just filter the water. And I didn't think that there would be enough flow inside the wreck to sustain them and feed them, but apparently there is, because they're there. And so it was really exciting to find that there was an unexpected community inside the shipwreck that we found with PPE.
Hey, thank you, Hannah. For me as well, going into the engine room right aft of the boilers with the PPE, seeing parts that that you just don't really ever get to see, such as the condenser, these parts of the engine, and then pipes moving up to the boiler, and actually a little bit of a peek of the boiler that powered the Portland for the first time. And you're seeing some of the engine and pipes that work, and these are really at the basement of the ship. And again, you know, at the basement everything's kind of hidden, but this is really what was keeping the ship going for as long as it was, for the Portland, which sank in 1898 and had struggled for hours against these heavy seas. So you're looking at what was keeping it alive and fighting against these gales and hurricane strength winds for the first time. And each little peek around the corner reveals something new, and we've just gotten the footage in, so I'm actually very excited. While this is the end of this voyage for this year, it's at really the beginning of the archaeology for me, and getting into the boiler room, both with the photographs and the 3D model that Evan and Mike showed you, provides insights that will provide information for months to years to come.
So I think Mike said it best about, you know, the most exciting thing about PPE was that she actually worked. We built her quickly, and you know, it really, she did everything that we wanted her to do. But I mean, for me, probably the most poignant moment was not what we saw, but where we managed to go. And just the thought that the first time we did that was just Monday night. We spent the day out there. We didn't even get in the water till 6, 7 o'clock in the evening. And we started going into these rooms at 9:30, 10 o'clock, even 11 o'clock at night. I think we were just coming out of the wreck. And, you know, we brought the ROV up on deck, and it was a relatively flat sea. There was a crimson red moon in the background, and we, you know, pulled the vehicles up. And we were all very happy that, of course, everything went well and it worked. And then, you know, it dawned on us that, you know, we were the first people to see these spaces since the ship went down. And you look at these valves, and Calvin talks about it a lot, you know, the forgotten workers and the people that made these things really work, and that they very well could have been there till the last minute, you know, trying to save the ship. And we may have been looking at some of those spaces, and we'll never know, of course, but no matter what, it helps remind us that no matter what we're doing, we're trying to speak and honor these people that passed away a long time ago. And that, I think for a lot of our team, was one of the more poignant parts of getting PPE in the wreck and helping to just tell their forgotten story.
Yeah, that is so incredible that this small device that you all developed can share such incredible stories through maritime archaeology and biology, really bringing a new life to tragedy of the Portland and Mystery Schooner. So with that, I want to thank all of you for joining. I really want to send a special thank you to our probably soaking wet research team over in Scituate, Massachusetts, for contributing so much knowledge to this project and letting us connect their knowledge to you today. I also want to thank the Inner Space Center team here at the University of Rhode Island for putting this production together so that we could share with you. There's also people working behind the scenes, Clea Harrelson and Ken Castell, who are managing the social media platforms, helping you learn more information about this project. We are finally concluded with all of the programs we're running, but we will be also sharing our recordings as well. And I forgot one other thank you, AV Watch. They're the group that actually enabled us to connect with you over these technologies. So a huge thank you to them as well. And with that, there's going to be more information you can find on our websites, sanctuaries.noaa.gov and hui.edu. You can also follow along with the hashtag Stellwagen Deep Dive across all of our social media channels. I hope to see you keep commenting in the threads, engaging in our resources, and learning more about Stellwagen Bank National Marine Sanctuary. Thank you for tuning in.